Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Neut, a fascinating new functional programming language. It's got some really unique features, especially its approach to memory management. Let's jump right in.
I'm eager to hear about this. From what I've skimmed, it seems Neut boasts static memory management without garbage collection, which is quite a feat. How does it pull that off?
Exactly. That's the core innovation. Instead of garbage collection or regions, Neut uses a type-directed approach. It translates each type into a function that handles resource management, copying or discarding values as needed. Clever, right?
That's incredibly clever. So, the compiler essentially ensures every variable is used only once? What happens if a variable is used multiple times?
Yeah, precisely. If a variable is used twice, the compiler automatically inserts a copy operation. For example, if you have a list used in 2 function calls, the compiler will create 2 copies to ensure each function operates on its own independent data. It's all done behind the scenes.
So no manual memory management, but also no runtime overhead from garbage collection. Sounds almost too good to be true. I'm curious though, copying large data structures like lists every time they're used seems inefficient. Doesn't that negate the performance benefits?
That's a great point. You're right to be skeptical. The initial thought is, oh no, copying a whole list just to get its length? That's a disaster. But Neut cleverly avoids excessive copying using something called the T-necessity operator from modal logic. It's a bit like Rust's borrowing, allowing for efficient resource sharing without unnecessary duplication. The details are in their static memory management documentation, but the gist is that it's far more nuanced than simple copying in most cases.
I see. So it's not always a full copy, it's more intelligent than that. That makes a lot more sense. What about the language's other features? What does the syntax look like?
The syntax is pretty clean and functional. It supports full lambda calculus, algebraic data types, and pattern matching. It's quite expressive, yet readable. Think of a blend of functional elegance with a practical approach to resource management. They even have a built-in formatter, similar to Go's, which is a nice touch.
That's excellent. And what about performance? How does it stack up against other languages?
They have benchmarks on their website, so you can check those out for a detailed comparison. But from what I understand, the performance is quite competitive. Remember, the absence of garbage collection is a significant performance advantage in many scenarios.
Interesting. So it's a functional language with static memory management, a type system based on calculus of constructions, and it compiles to LLVMIR. It even has built-in LSP support and a rapid prototyping experience. That's a pretty compelling combination.
Absolutely. And one more interesting detail is their module system. It uses checksums of tarballs to identify modules, which is a unique approach to versioning and dependency management. It's not the central focus, but it's a noteworthy aspect of the design.
Fascinating. It sounds like Neut is a language worth keeping an eye on. The combination of functional purity, static memory management without GC, and the innovative type system makes it a truly unique offering. Thanks for the overview.
My pleasure. It's definitely a language to watch. And remember, listeners, you can find all the details and links mentioned on the Neut website. Thanks for tuning in to Tech Bytes and News. Have a great day.
Bye-bye.